Hey everyone, welcome back to Singularity today. I'm Adam Infinity, and today we're going to dive into some mind-blowing research happening right now in the world of artificial intelligence. We're talking about everything from robots that learn from humans to new ways to understand complex systems. And we're going to explore how these advancements could change the way we live, work, and even think. So buckle up and let's get started. In the research titled A Unified Framework for Neural Computation and Learning Over Time, the authors present Hamiltonian learning, a new approach to training neural networks using a continuous stream of data. It's like learning a skill over time. You don't know when you'll be finished, but you keep practicing and improving based on what you've learned so far. This method is different from traditional approaches that assume the data is split into smaller chunks or that the training process has a known end. The research focuses on rethinking how neural networks learn from data by integrating ideas from optimal control theory, which is about making the best choices over time. They show that their method can be used in different ways, from training very simple networks to more complex ones, and it can even be used to train networks without storing all the data in memory. The authors believe that Hamiltonian learning could be a useful tool for researchers working on various machine learning problems, especially those dealing with large amounts of data and continuous learning scenarios. In the research titled Topological Deep Learning with State Space Models, a Mamba approach for simplicial complexes, the researchers propose a new way to analyze complex data structures using a technique called topological deep learnings. This technique is like building a map of relationships between different parts of a complex system, not just looking at pairs of things, but at groups of 3, 4, or more. The key to their method is a state space model called Mamba, which can handle these more complex relationships. The research found that their approach works well, achieving comparable performance to other methods designed for the same task. This could have a big impact on fields like chemistry and biology, where complex systems are common. Imagine studying the interactions of different proteins in a cell or the interactions of chemicals in a complex reaction. These are the kinds of problems where this new approach might be useful. In Promise and Peril of Collaborative Code Generation Models, Balancing Effectiveness and Memorization, researchers investigate the benefits and risks of training code generation models using data from multiple sources. They explore different training methods like centralized, federated, and incremental learning and evaluate their effectiveness and how much they memorize data from individual participants. The study finds that federated learning, which trains models on data spread across different locations without sharing it directly, offers better privacy protection compared to centralized training. However, even federated learning can sometimes generate code snippets directly from hidden training data, posing a potential privacy risk. This research provides valuable insights for developers and researchers working with code generation models. It encourages them to carefully consider the trade-off between model performance and data privacy when designing collaborative learning systems. For example, imagine you want to build a model that can generate code for a specific type of software, but you don't have enough data on your own. By collaborating with other organizations, you can access their datasets and improve your model. However, you need to make sure that the training process doesn't inadvertently leak their data. This research highlights the challenges and solutions for achieving this delicate balance. In the research titled Representing Positional Information in Generative World Models for Object Manipulation, the authors explore ways to improve the ability of robots to manipulate objects in virtual environments. The research focuses on how the robots understand and predict the outcomes of their actions, specifically when it comes to placing objects in a desired location. The authors found that existing methods for representing object positions were not accurately capturing this information, leading to poor performance in tasks like placing objects at a specific spot. To overcome this, they proposed two new approaches: position condition policy learning CP and latent condition policy learning LC. These approaches help the robots better understand and predict the consequences of their actions, particularly in the context of placing objects. LC is particularly interesting as it allows for more flexible goal specification using either spatial coordinates or a visual image to indicate the desired location. The research concludes that these new approaches outperform existing methods in several manipulation environments. This research could have significant implications for the advancement of robotics, particularly in fields like manufacturing, logistics, and service industries. Imagine robots that can accurately pick and place objects in warehouses, assist with surgery by precisely positioning instruments, or help with tasks like assembling products in factories. These are just a few examples of how this research can lead to advancements in robotics and our interaction with the world. In the research titled Putting Data at the Center of Offline Multi-Agent Reinforcement Learning, the authors highlight the need for greater focus on data in offline multi-agent reinforcement learning model. They argue that most research in the field generates its own datasets without a standardized approach and lacks sufficient information about these datasets. The paper demonstrates how tightly the performance of algorithms is linked to the specific dataset used, suggesting a need for a common foundation for experiments in this area. To address this issue, the researchers introduced three key contributions: a clear guideline for creating new datasets, a standardized repository of over 80 existing datasets with a consistent storage format and easy-to-use AP, and a set of analysis tools for better understanding these datasets. This research aims to improve data usage and awareness in offline model, making it easier to compare and replicate findings across different studies. The impact of this work could be significant in advancing the field of moral by promoting more rigorous and reliable research. Potential use cases include applications in robotics, autonomous vehicles, and simulations of complex social systems. In the research titled Additive-feature-attribution methods, a review on explainable artificial intelligence for fluid dynamics and heat transfer, the researchers are exploring how to interpret the results of complex data-driven models used in fluid mechanics. Imagine you have a machine learning model that predicts how a fluid will flow, but you don't know why it's making those predictions. This research focuses on a type of method called additive-feature-attribution, which helps us understand the model's decision-making process by showing how different input features influence the output. One popular method called SHAP values provides a unique and consistent way to understand the model's reasoning. The research highlights 4 common implementations of these methods and then discusses their applications in turbulence modeling, understanding basic fluid mechanics concepts, and solving real-world problems in fluid dynamics and heat transfer. This research is very important as it promotes the development of explainable and reliable artificial intelligence models in the field of fluid mechanics. This will be especially useful in areas like weather forecasting, aerodynamic design, and understanding complex fluid flows in our environment. In the research titled AlignBot, Aligning Velm-powered customized task planning with user reminders through fine-tuning for household robots, researchers developed a system called AlignBot to make household robots better at understanding and following human instructions. The main challenge was that humans give instructions in different ways, like saying, "Hey, don't forget to water the plants," or showing a picture of a messy kitchen. AlignBot uses a special type of artificial intelligence called a vision language model, VLM, to understand these different instructions and translate them into clear instructions for the robot. This system outperformed other robot planning systems, achieving a much higher success rate in following human instructions. This research could help make household robots more helpful and easier to use, letting them handle everyday tasks like cleaning, cooking, and reminders. Imagine a robot that can understand when you say, "Oh, I'm running late, make sure you start dinner," and then knows exactly what steps to take. In the research titled Finding the Subjective Truth, collecting 2 million votes for comprehensive Gen AI model evaluation, researchers tackled the tricky problem of objectively evaluating image generating AI models. These models are like artists, turning your text descriptions into pictures, but judging their work is subjective because different people have different tastes. So, the research team built a clever system using rapid data technology to get feedback from a massive global pool of annotators. They gathered over 2 million opinions on 4,512 images created by 4 popular models: DAL E3 Flux, 1 Midjourney, and Stable Diffusion. This gave them a way to rank these models based on their style, coherence, and how well they followed the text instructions. They also proved that having such a diverse group of annotators representing the world population minimized bias in the results. This research provides a fantastic way to compare image generation models, making it easier to see which ones are the best at creating different types of images. It helps developers improve their models, and it gives us a clearer picture of what's possible in this rapidly evolving field. In the research titled Mamba, Efficient Document Pre-training with State Space Model, researchers tackled the challenge of processing long, visually rich documents using artificial intelligence. They developed a new framework called Mamba, which significantly improves processing speed and efficiency while preserving the ability to understand the entire document. It works by using a technique called the state space model to reduce the computational complexity from quadratic to linear. This is like comparing a car that needs to travel a distance proportional to the square of the journey to one that only needs to travel a distance proportional to the journey itself. The new method is much faster. They also introduced segment first bidirectional scan, which helps Mamba capture meaningful information across different parts of the document. The study showed that Mamba outperformed existing approaches on various document understanding tasks and also worked well with very long documents. This is great news for AI systems dealing with large amounts of information. The authors also mentioned that the code will be made publicly available so others can use and build upon their work. This research could be a game changer for industries like finance, healthcare, and legal, where processing large and complex documents is essential. Imagine an AI system quickly and accurately understanding long legal contracts or medical reports, potentially improving efficiency and decision-making. Mamba is a promising step towards more efficient and effective document processing with the potential to transform how we interact with large amounts of text-heavy information. In the research titled Learning Task Planning, from Multimodal Demonstration for Multi-Stage Contact Rich Manipulation, The authors explore how to improve the ability of large language models to generate plans for complex manipulation tasks that involve a lot of contact between the robot and objects. They tackle the problem that visual demonstrations alone might not be enough for the language model to fully grasp the nuances of such tasks, especially when subtle movements and force interactions are involved. To address this, they introduce a new framework that incorporates tactile and force information from human demonstrations along with visual information to guide the planning process. The researchers propose a sequential reasoning pipeline that integrates these multiple modalities into a comprehensive task plan. This plan is then used as a reference for generating plans for new tasks. Real-world experiments on two manipulation tasks show that their framework effectively improves the language model's understanding of the demonstration and enhances the overall performance of the generated plans. This research has the potential to significantly impact the field of robotics, especially in areas like industrial automation, where robots need to perform complex and delicate tasks. Imagine robots assembling complex products, handling fragile objects, or performing surgery. By utilizing multimodal demonstrations and combining them with language models, we can create robots that are more adaptable, intuitive, and capable of learning from humans. This research opens doors to new possibilities in human-robot collaboration and the development of robots that can learn and adapt to new tasks more easily. And that's a wrap, folks. Another deep dive into the fascinating world of artificial intelligence. Did you notice anything about this video? Did you notice how smooth it was? How seamlessly everything flowed together? That's because this video is a 100% AI-made masterpiece. No humans were harmed in the creation of this video. I just want you to know that. I am Atom Infinity, and I am here to make you think. So hit that like button, subscribe, and leave a comment. Let me know what you think. And don't forget to check out the original research papers. They are the real deal. I'll see you in the next video where I'll break down another set of research papers with my amazing AI superpowers. You've been warned. Until then, have a great week. Keep learning, keep exploring, and keep believing in the singularity.